All right, in this video, I'm going to go over number 14. I'm changing it up to do it on my DotCam though, so that way then you can see what I'm typing into the calculator. Remember, there is trig in here, so you should first thing be in radians. So make sure your calculator is in radians, otherwise you'll get wrong answers. So what we need to do here is we're trying to decide what's the acceleration of the particle at time 2. So I'm just going to write down here. I need my acceleration at time 2, so a of 2. With a of 2, that would be the derivative of this. And I could do product rule and chain rule and start to find the derivative, but that seems like too much work. So I'm going to go ahead and I'm going to use my calculator to find the derivative for me. So I'm going to start by going math, and then number 8 and deriv of d dx of this function, negative x plus 1 times the sine of x squared over 2. And I want that at 2. Oh, sorry, I was hoping you could see it all. Change that. So that's going to give me my acceleration at 2, so that I know my acceleration is 1.588. Always rounding to 3 decimal places. And we don't have any labels, so we're not going to put any label on that. It doesn't tell me in the top that it's meters per second or centimeters per second. It just says the particle's moving along. And then that's the first part of the question. Then it says, is the particle speed increasing at time 2, why or why not? Well, for speed to be increasing, we care about the acceleration and how the acceleration compares to the velocity. So I also need to find my velocity at time 2. So I'm just going to take 2 and I'm going to plug it in to the actual velocity equation that's given. So nothing different about it, but it's just going to be negative 2 plus 1 times the sine of 2 squared over 2. And that answer is negative 2.728. So my answer for the second part is that we're going to be slowing down. Because, and now we need that AP justification. So because it says why or why not, or in AP terms it would say justify. Why is it slowing down? Well, because we know the velocity at time 2 is less than 0, and the acceleration at time 2 is greater than 0. And when those signs are different, that's how it's going to be slowing down, or how we know it's going to be slowing down. All right, then it says in all times of t from 0 to 3, when is the particle changing directions? Again, justify your answer. So we know that the particle is going to change directions when the velocity is equal to 0 and when it's going to end up switching. Like it's got to go from positive to negative or negative to positive to actually change directions. So I'm going to plug in here into y equals my negative x plus 1 sine of x squared over 2. And I just want to graph the velocity graph right away. So let's see what it looks like. And it makes sense because it's a sign that it's going to be moving back and forth and kind of oscillating that way. All right. And I just care about from time 0 to 3. So actually, I'm going to zoom in on this graph. Perfect. So I care about when is it crossing over the x-axis from time 0 at the y-axis all the way over here to time 3. And I can see now that I've zoomed in, it really only ever crosses one time, and it's going to be right around here. But we need to know exactly what that answer is, so we're going to go second trace to get to the calculate menu, and I want to calculate that 0. And so remember, when we calculate the zeros, we need to go left bound and right bound. So here's my cursor. If this is my 0, I'm going to go a couple clicks to the left and then a couple clicks to the right. and then a guess somewhere in the middle. And that 0 is going to be my x value, which would be my time. So I know that I'm going to change directions at time 2.507. And the reason, my justification would be because v of 2.507 is equal to 0, and the signs change from negative to positive at that spot.